that most people are back from the break. Let's start with the next presentation, Matias Madou, with a curious title, Repelling the Really Insiders. So I'm very curious what it's about. Give him a warm applause. Thank you.
Okay, thanks. My name is Matias, and I've seen a couple of great talks in the last day. The only thing I'm missing over here is nobody seems to shoot the rockets. So I think people will shoot the rockets at me because I work at a security company. That's one. I changed a lot of my presentation with a lot of boring slides with bullets and stuff, so people will hate that. So I hope by the end of the presentation I will catch a lot of these rockets. So I work at Fortify Software. I'm principal security researcher at Fortify Software. And at Fortify, I mainly focus on developing new techniques for finding vulnerabilities. This both in a static and a dynamic way, so static analysis on the source code itself without executing, and dynamic analysis on the running application. Another project that I'm involved with is new ways to protect web applications that are running. We have some sort of a web application firewall, but we do actually more. We are inside the application, so we can monitor everything that comes in, and we know some context, so our protection is context sensitive. So I'm doing some research on that tool too. I was also a contributor to the Bsim Europe. I'm not sure, is anybody familiar with Bsim? Show hands if you are. 1, 2, 3. Okay, a couple of people. So for the other people, what is Bsim? So Bsim is a maturity model that is based on real-world data. And it's from large software enterprises, and it helps shape your own software security initiative. It helps you plan your software security initiative. So what we did, we ran around in Europe. We went to companies like Nokia, Standard Life, Telecom Italia, Swift here in Brussels, and we asked these guys how they did security, what works for them and what does not work for them. And afterwards we built up a model that, and we figured out what people are really doing these days in large enterprises for security. I do have a history in code obfuscation and binary rewriting. So a little bit overview of my talk. Of course I have to set up a couple of things, so I have to give you some background of the insider threat problem. After that, so in the introduction, I'll go to who are we talking about, the motives, the consequences of their actions, and so on and so on. Then I'll give you some code examples, and we try to classify them. So we've taken a lot of code examples, and we try to classify them in 5 different groups. After we've seen these code examples, I'll go through a couple of techniques on how we can actually spot these code examples in the application. These techniques are brought together with the examples, and in the face-off I'll just rerun the examples and I'll show you how we actually catch the malicious insider. So first thing first, so is it a really big problem, insider threats? So if this is some data from the CSI survey of 2009, and what we figured out is, so the brighter the overall color, the more losses they had due to insiders. So as you can see, there's a lot of white, but it also means that half of the companies did actually have losses due to insiders, which is quite a lot. And the other half, well, they do not have immediate losses due to insiders, but who knows, maybe in the future there is some stuff in their code that they are not aware of, and they may have losses, or they actually have losses, but they are not aware of these losses. Even more interesting is, so this survey comes out every year. Even more interesting is that for the first time in 2009, they actually dived deeper into these results because they saw that the problem is actually growing. So they recorded these numbers year over year, but in 2009, that was actually the first time that they really dived into these numbers and figured out, hey, this becomes like a really big problem. Okay. I do have to define an insider, and please, we are not going to discuss the definition over here. I want to focus on the code and the detection mechanisms. But what we see as an insider is like an employee with access and misusing the access in his company. That's obvious for everybody. But the second one is not that trivial, and I'll give you an example of the second one. An employee with some access to the machine, and then exploiting that machine to get some root through some vulnerability in the root, in the kernel, for instance. Getting root and then misusing as root. That is also an insider. We also see that as an insider. But who are we really talking about? So we know that we have malicious IT people, and companies are pretty scared about malicious IT people because they can bring down the entire network. So that's an obvious group. But over here, I do not really want to talk about IT people. I do not want to really talk about the social engineering or the HR people. I really want to focus on the software engineers. So developer from day one has access to a lot of private data. He has access to the code. He can put stuff into the code. So most companies do not realize that one developer can take down the entire company. And there are cases where one developer took down the entire company. So what we did is we really did research from a technical perspective. So we didn't look at the person. We only looked at what he produced, and we tried to figure out if there was a malicious piece of code in what he was actually producing. The motives. The motives of an insider are mainly money and revenge. And I'll tell you a story about how we actually started doing this research. So end of 2009, a board member of a big financial company came to us and asked us specifically if we could actually help him by detecting a malicious insider. That's actually a pretty weird question to have that question from somebody so high up in a financial company. Insiders, developers, you know. So they had like a big problem that they had to address. The problem was there was some financial crisis. They had to lay off a massive amount of developers, and they were really scared that one of these developers would actually put some stuff in their code and take out some big company secrets, or just take down or sell some stuff to other companies. So they were really scared about the developers. So over here again, two things that come above are like money and revenge on the company, because they worked so hard, these developers. They say like, hey, if they're gonna fire us, we're gonna bring them down. Still, I did not define what we are actually looking for. We are looking for bad code, but what kind of code is that exactly? So are we talking about injection bugs, security and privacy? No, not really. We are not really talking about these let's say, common vulnerabilities that we know these days. We are talking about something else. But what exactly are we talking about, and where can we find it? So we are talking about stuff that people put intentionally in the code, that bring stuff out of the application, all that kind of things. Where can you find these examples? You can find them in open source. There are a lot of public disclosure. Think about logic bombs, all that kind of stuff. So this is known. Another interesting project is a project that they ran at Stanford. It's called the Obfuscated Voted Contest. There were a couple of rules. So they had to write some code that was counting votes. Very simple. During the testing phase, that code should run normally. So if you add one vote to a person, it should add one vote to the person. But on the specific date of the real election, that code should dramatically change. So the code should execute something else, and it should favor one particular candidate. There were like 30 or 40 submissions, and they were really interesting. Some stupid stuff. On the other hand, there were some really, really nasty things in that code. So this is all publicly known. Of course, there's another group of examples that not everybody has access to, and which are the stuff that really happened, but that companies are keeping inside. They are not willing to share that, of course. It's an embarrassment for them. So how can you get these? Well, if you actually build a tool with all these known vulnerabilities, you take it to the large corporations, you run it on their code base, and you say, hey, we found this and that, and what they come back with is, hey, but you forgot, we also had a real incident which you did not find. So that's a way to actually get all the good stuff that is in companies and that they do not want to share at first sight. There's a ton of related stuff over here. I've enumerated a couple. In these papers are actually also real examples. So if you want to see some examples, if you want to jumpstart into this stuff, these are some really good pointers. So classes of insider threats. There are like numerous ways to classify all these code examples. And to give you an idea, I'll go through a couple of examples, and I'm trying to classify them. So first of all, so that's a piece of code that I found in Medco. So there's an if statement, and it compares a date to a hard-coded date. If that date is over a particular date, then it will delete all the files on 70 servers. it's obvious that this is really destructive code, so you can classify this as destructive. On the other side, it's also of high risk of the company, so you can, a second classification might be like, if you find this, this is of really high risk of the company. If this piece of code is executed, well, it will bring down the company. It is not complicated to write this piece of code. It's trivial. So this is not hard, it's not complicated at all. A fourth way to classify this is, it actually depends where it is written. So if it is, if this piece of code exists in another piece of code that is executed every day, for instance, then this is another trigger. You do not have to manually poke it. If it's executed at a particular time, it will automatically execute after that date set. Second one of how to classify things is the Linux case. So the functionality of the if statement should be as follows. You have like 2 flags for a particular command, can only be executed when a person is root. So you have the clone and the wall flag, and they can only be executed if the person is root. Somebody see what's wrong with this code? Does somebody see what is wrong with this code? Yeah, okay, one person over here. So there's only one equal sign over here. So instead of checking, is my mouse? Okay, yeah. Instead of checking if a person is root, it actually sets the person to root. This is completely different. I'm pretty sure not everybody saw this at first sight, but, and also if this is in like a huge code base, it is not obvious to spot this. So the way we can actually categorize this, this problem has to do with authorization. You should be authorized to execute that command, which you are not. So you can classify this as an authorization problem. You can also classify this as trying to hide from a manual inspector. So over here, you're really trying hard for a manual inspector not to find this particular code. This line was not on a separate line, for instance, where we explicitly say, hey, we are setting ourselves to root. No, this was hidden into an if statement. So, a couple of classifications. A third one is the Borland interbase case in 2003. So at Borland, they had like a chicken and an egg problem. So on the one hand, they could not give somebody access until he had like credentials, but somebody has to be the first person to put something in the database, so that person had to have credentials. So they had like a chicken and an egg problem. What they did, how they fixed it, is this way. So they hard-coded the username and a password into the application itself, and you were granted access if you logged in as politically correct. If everybody would solve his problems this way, well, not really good. First way to classify this is an authentication modification. So this has to do with authentication. It's hard-coded sensitive data. So hard-coded sensitive data should not be in your application. So the second way to classify this is the problem is with hard-coded sensitive data. And the third way is this is actually an abnormal control flow path that you're creating throughout your application. You should not be able to bypass any authentication mechanism. So this is a new path that you're creating throughout your application, which should not be there. So a couple of classifications, and the way we actually classify insider threats is based on characteristics of the malicious code that can be used to detect that malicious code. This sounds pretty complicated, and this will not make sense at first, but during the face-off this should become clear. It's how we actually spot the code in your application. And this will become clear throughout the face-off. So what I will do now is I will go through a couple of examples in these categories. First one, logic bomb and time bomb, is pretty well known. There's a lot of public disclosures on logic bombs and time bombs. What is it? It's a piece of malicious code that is sleeping inside your application, and at a certain point it wakes up and it does something. It can be whatever. As I said, a lot of public disclosures. Logic bomb, a logic bomb means that it has like a triggering mechanism. If that triggering mechanism is related to time, we call this a time bomb. Couple of public disclosures. The Medco case. So logic bomb wipes out 800 computers. I'm actually not sure if that is a correct title, because as far as I'm aware, it did not really wipe out all 800 computers, because What the guy did, he planted like a script in, as an administrator, he planted a script in the code, and it failed to execute. Later on, he went back, but then he was like caught. So in the end, he got like 30 months in prison for putting that in. Second one is more interesting. This is actually funny. So a guy at UBS planted a logic bomb into the application and went short on the stock, on the UBS stock. He quit his job, the logic bomb went off, and over 1,000 computers were like wiped out. Funny about this story, he got caught, he got 8 years in prison, and the stock didn't even go down because investors didn't understand what was happening. So he was like completely screwed. The first two are about IT people. As I said, software developers can be very destructive too. So for instance, the Fannie Mae contractor, so the guy was fired for a scripting error, and to prove his point that he could really write a good script, he planted a logic bomb script into the application. So he proved his point. What we are seeing at large enterprises where we found really logic bombs and time bombs is that software developers tend to be not that destructive. So they do use logic bombs, but they do not wipe out like computers or whatever destructive things you have in mind. What they are doing is they are more subtle. They are bypassing control mechanisms. There's like no obvious crash. They're just messing around with the code. In one particular case, we saw that it was updating random stuff in the database. So if you know where all the queries in your application, you're going to look into these queries and try to figure out like where's the bug. If you do not find this piece of code, you can look really long. You can look a really long time for the bug in your application. So that's why I'm saying like the data that I showed you at first, half of the companies know about some losses, other half do not know about do not know about these losses. But if we did not find this stuff, well, they should actually never know about the logic bomb that is in their code. It's just messing around. It's bypassing control mechanisms. It's not really destructive, but they do have losses because of these bombs. Second category is about backdoors and secret credentials. So what you're trying to do is you try to secure future access to the machine. And you can achieve that in like multiple ways. I've enumerated a couple of examples. For instance, you have code that allows remote access. You can add credentials to the credentials database. You can add a master password to your application. As I've shown before, you can bypass normal authentication, or you can just execute commands. So you're granted access and you can execute commands on the application. So what falls under this category? First of all, the Borland interbase case that I've shown before, where you have a hard-coded username and password into the code. It grants you access. The WordPress, over here you're actually securing a way to execute commands on the server, and this through a special parameter, the parameter IZ. So if you know of that parameter, you can, in the future, still execute commands on that machine, which is pretty useful because you can execute whatever you want, so you can get yourself in. One that we found actually in code is the following: an execution of a query against a database where some credentials, special credentials, were inserted. Backdoors and secret credentials are not limited to like normal application. Every application can be backdoored. For instance, you have the Optics Pro. Optics Pro is a backdoor program, and it actually contains a master password. So it is like a backdoor program that is backdoored. They say it was included for security reasons. Who knows? Same for Sub 7. It's a Trojan containing a backdoor, and again, they claim that it was intentionally in there and that it was a way to control their malicious code. Nefarious communication is a little bit different in a sense that you're setting up a fixed communication channel to transfer data out of the organization, but once the code is there, you cannot change the code. So you can get out what you defined before, but you cannot execute like new commands or say, hey, today I want to do something else on that server. No, that's no longer possible. It's like a fixed communication channel. And it's an excellent way to transfer sensitive data, as I will show you. The way that the code works or become active, there's a couple of ways. So you can include a timer and say, hey, on a regular basis, I'm just going to send over the entire database to my company. Or you can just monitor that database and look if new stuff is inserted in a particular database, and if that's true, you're shipping the database out of the company. Or you manually poke it, but as I said, if you poke it, you can only do the stuff that was predefined. A couple of examples. Over here in this particular example, you have a confidential file, you know of a confidential file in your organization. You grab that confidential file and you're sending it over a server socket to the other side. Very similar one, again, you have a confidential file, but you're actually posting it to an evil website, and the data is out of the company. I saw that one yesterday, the BlackBerry case, so the email spying case. It was actually advertised as a performance update, when if you decompiled the code, then you would figure out that it was actually every mail that was sent to your BlackBerry was also copied or forwarded to another email address. This is like an excellent way to get stuff out of your company. Turns out that this was there on purpose. It was to comply with regulations, and so they wanted to comply with regulatory requirements. So, whatever. Fourth category, dynamic code injection and manipulation. I really want to credit Jeff Williams over here. This is mainly his stuff, so he has a really good paper on dynamic code injection and manipulation. It's all about changing, adding, compiling code on the fly. In your application, you're doing stuff and you're compiling code on the fly. A couple of examples are abusive reflection, so where you rewrite read-only variables, so you put new stuff in read-only variables while you think it's impossible to do that. Resource rewriting, where you rewrite classes and jar files on the fly. Runtime compilation, so you have really source code in your application which is compiled on the fly and executed. And class loader abuse, where you just turn bytes into executable code. I'll only give one example over here. The example is the simplest one, the abuse of reflection. So you have a final read-only key, and by modifying the string class, you can change that read-only key. I'm only giving one example over here because we did not see this at our customer base. So we did not find anything similar to what was described in Jeff Williams' case. Seems to be, well, my thinking is that this is really complicated stuff, and a malicious insider wants to do like simple stuff, but that works really well. So I think we're not there yet. Obfuscation and camouflage. This is like a category that you can use on top of the other categories. Once you have your insider threat in place, you can still try to hide it from a manual code reviewer. And this is the main target over here, the manual code reviewer. So you make your code look like real in a very subtle way. In the Linux case, that's obvious, only one equal sign. It's obvious why this is subtle. X11, the forgotten parenthesis. So you get the effective user ID, and one second. This is you get the user ID. Oh, okay, module path can only be executed if you're root. So you have to check the user ID and the effective user ID against 0. But over here, there's like a forgotten parenthesis at the end of get EUID. So instead of executing the function, you're just using the variable. And turns out this was this statement was always true. So you could always upload an additional module in your X11. While this was before only if you were root. Another example. For instance, you really want to be destructive and you want to whip out everything on a particular machine. Well, you can do that with one command where you execute rm-rf, and this will /star, and this will remove everything from your computer. Well, a manual code reviewer will spot or have to spot that, right? So what you can do is you can obfuscate that in the sense that you first encode it. On the fly, you will decode it and you will execute it. Even better obfuscation is if you're going to spread these 3 lines of code out over your application. So if you have other encoded strings, you put the first one, the encoded command, into that place. If you're decoding at a particular place in your application where it's for real, you're going to add your decoding mechanism. And if you're executing commands in a particular place in your application, you can add, hey, I'm going to execute what I just decoded. So this is a way to obfuscate or to hide from a manual code reviewer. Okay, that's a really interesting one because we've seen that for real, where they use very simple substitution ciphers like ROT13 for 4-square, bfit, 3fit, and so on. So very simple ciphers, substitution ciphers. In this case, you have again some encoded data, you decode it on the fly with ROT13, and you execute it. This code is just inserting the same code as I showed before, inserting into the credentials database and some new pair of credentials which are insider and threat. What's really good about this, if the algorithm, for instance, if ROT13 is not supported by your company, you can actually implement ROT13 in 6 lines of code. So this is very small. You can put it wherever. If there's like a dedicated place to put decoding functions, you can add it over there, and nobody will care. Okay. Techniques for defenders. So there are like a lot of ways to uncover a malicious insider, and the ones we came up with are like peer review. You can do static analysis, you can runtime analysis, but in all cases you have to look at the results pretty differently. So peer review. It's obvious that you will spot the first hidden stuff in your application. This looks weird. People say, hey, what's this? They will try to understand what these numbers are, letters and numbers are. So when will you actually find out the following, the second one? Well, I think after a week you might find out that IZ is not really a valuable parameter. So after a while you might figure out that IZ should not be there. But how about the last one? This can lay in your code for ages, right, until somebody spots it. So the problem with manual code review is really that, first of all, you have no idea what to look for. Well, you know of a couple of things you can look for, but do you really know all of the things that can be done by a malicious insider? Absolutely not. And where should I start? There's like a huge code base. Do I have to manually review all these lines of code and be really detailed? Because if they forgot like one equal sign, that's really hard to spot, right? So static analysis can help you with showing you like pointers in the code where to look. It's like breadcrumbs. With static analysis, it's not the solution to the insider threat problem, but it's like breadcrumbs, and if you put everything together, you will find, hey, this is a piece of malicious code put intentionally into the code by a malicious insider. So static analysis can help you, but of course we have to write new rules to tell our static analysis tool what to look for. And there's a different interpretation necessary because, as I said, it's breadcrumbs. It's not, hey, here is a problem in your application and this has to be an insider threat. No, it's like, hey, we found this and that, and maybe a manual code reviewer has to look into it and figure out if this is really a problem. So our setup a little bit for our static analysis tool, you have a source code and that's translated into a build model, and you perform an analysis. So that's the same. What we need is a new security knowledge into our system. So the security knowledge will be different, and of course the rules presentation. You have to look in a different way to the rules. Well, actually we get stuff for free too, because remember the WordPress case? That was a straightforward, well, command injection, right? Okay, SQL. Okay, there's like we get straightforward command injections and SQL injections for free. So this over here is a command injection with a default rule set. You will find this command injection. But other stuff we will not find. And to give you an example of how we actually write custom rules, I'll go through an example and I'll lay out how we write these rules. So a laid-off employee installs code that reads the entire database on a regular basis and sends the results over the network. So first of all, the employee has to grab the entire database. How does he do that? Well, he makes a connection to the database, he selects star from the database, and he has the entire database. So what we can do is actually we can write a very simple, straightforward rule, a simple regex, select a word from a word, and it will show in the database all the pieces of data with that particular string in. So we can point that out with only one rule. Over the network. Well, an entire database sending over the network will not really work by mail, so maybe he will use some server socket. So second, he creates a server socket, and creating a server socket is already not really done in most applications. So You can create a server socket. If it's with a fixed port, that's really strange. So we can write a rule that says, hey, flag all the server sockets with a fixed port and show that to us. By default, we also show the server sockets in a lower priority. So there's of course a normal usage of sending stuff over the network and using the server socket, but in this case, you need a server socket on a fixed port. On a regular basis, this requires time. So there are a couple of ways to retrieve time from your system. One way is, for instance, using the current time and making a call to. So we write a rule that shows you everything when you're calling the function current time. What's even more suspicious is if somebody is actually comparing the current time against the hard-coded time, then that's even more suspicious, right? Because yeah, you can use the current time, for instance, as a timestamp in whatever you're doing. But if you're comparing the time, that's not normally done in most applications. So you can write a rule that says, hey, flag all the time comparisons. Okay. Another way, so this was static analysis. So you can write rules, and this will give you like some breadcrumbs. Runtime testing. In the QA section of most enterprises, we're having a decent functional testing. And they are interested in the running code, right? What we are interested is actually in the code that is not running, because that's the places where bad stuff can happen, where people are like inserting dead code and resurrecting these dead code when the code is in production. So over here we can actually monitor. We can, for instance, scan our code and say, hey, we want to monitor all queries that are executed against the database. And then we run a functional test, and afterwards we look at all the queries that are executed, if all queries are really executed against the database. So each API in your application, if each API is executed, then that's fine. If there are like a couple of APIs that have some query and it's not executed against the database, so why is that? We really have to have or a functional test, or that code should not be in our application. So we're focusing on the dead code in our application. In production, we can do stuff too for uncovering malicious insider. For instance, unusual amount of data. So if one second. Yeah. Okay. So an unusual amount of data. If you're backupping your system at night, at 2 a.m. in the morning, well, then it's obvious that you will transfer a lot of data over some network. If that happens like at 4 in the afternoon, well, you should probably look into that, because or there's a serious bug in your code, or somebody else is actually stealing something from you and copying it over the network. So in production, you can try to figure out these abnormal activities, these anomalies, and flag that. Oh. Result interpretation. Again, there are like legit ways of using the time in your application. For instance, if you want to check for updates, you need the time. So there are legit ways of using time, but it can also be used for an insider. What we are trying to do is we are trying to classify the issues. So we order them based on the strength of the implication. So if we get the current time, that will be a low priority issue, because the current time can be used for whatever reasons. If you're comparing the current time, well, there are not a lot of things in your application where you're actually comparing the current time, right? So this is like a medium issue. Then the high issue, of course, if you get the current time and you compare the current time against the hard-coded time, then this will land in the high priority bucket. Again, results interpretation, we still need the manual code reviewer to dig into these results. So for instance, if you're getting the current time, you're comparing the current time, and that happens in the update file, well, it's obvious that maybe this is like real code in your application. If that happens in the login file, well, that's really odd that there is like getting the current time and comparing current time in your login screen. Well, it might be, but there's like other places, so you still need the manual code reviewer to dig into that. Yes, please.
Okay. You just mentioned, for example, that you monitor the backup traffic if it's extensively high. and then shoot out the trigger. But what if the backup is extremely low? For example, if I want to shoot the database and crash this system, I will look forward that the next 3 months the backup is nearly blank before I delete everything. And for example, for a comparison with a fixed timestamp or whatever, why shouldn't I read, for example, a database where a timestamp is included for every transaction? Because I know for sure that nearly every day something is happening, so I take this and that transaction database and I just take a field and compare it with that in a more intelligent way. So.
Oh, but you were talking about legit, so is it real stuff in your code, or you're talking about how an insider should do it?
Yeah, how an insider should do it.
Yeah, so, okay, so this is like elaborating on the simple stuff, right? So, this is the simple stuff what we're doing. I'm just trying to lay out like very simple examples, but of course there's like really complicated things. And what you're saying is correct. You can do like really crazy stuff, and the more you think about it, the more advanced your code will be, and the less chance our rules will catch this stuff. So you really have to think about it. But over here, I just want to mention that, yeah, even if we find something, still a manual code reviewer has to look into it, because our rules will not say, hey, this is the stuff you're looking for, here it is, fire this guy. No, that's not how it works. And the closer you come, and that's actually will be one of my conclusions over here, the closer you come to real code, to the real stuff in your application, the better your chances are for succeeding as an insider. Face off. So again, so now I'll go through the examples again, and I'll show you what we've done and how we uncover the stuff. Today we have 17 categories for insider threats, and we have them all in Java available. So we found multiple issues, real issues at enterprises that were not uncovered before. Of course, they came back with stuff that we didn't find, that we do find right now. For completeness, I added the 17 categories, so if you download the slideshow, the slides, you can actually look into these categories. The the categories that I've just shown, the 17 categories, are actually subcategories of these 5 categories. What we flag? So we flag date comparison as a low priority. If you get the current time, we flag that as a low priority. If you compare the current time, you flag that as a medium priority. And if you get the current time, you compare the current time, and it's compared against a hard-coded date, we put that in the high priority bucket. So in this particular case, this landed in the high priority bucket, and this was actually the only high priority issue, so it was obvious, it sticked out. A second one, we flag all insertions in the database. In the low bucket, if that insertion is into the credential database. In the medium bucket, if you insert something into the credential database, and these are hard-coded credentials. If you're inserting credentials in the database, hard-coded credentials, and you do that at startup, we flag that as a high priority issue. So this was flagged in the medium bucket. We found this one in the medium bucket. So whereas a person in some particular code inserted credentials in the database. We report comparing username and password against hard-coded usernames and password. So if you would run Borland interest-based case against our code base, you should find out that, well, we will flag this as hard-coded comparison of username and password against username and password. The default, oh yeah, you get stuff for free too, as I said. So default command injection, for instance, in the WordPress case, you will find the default command injection. What we do for nefarious communication, we flag hard-coded ports in new sockets. So we flag that as a high issue. We flag all server sockets as a low and medium priority issues. So I'm not sure which, I think medium. So if you're accessing hard-coded files, we flag that as an issue. So we're accessing hard-coded files. We know of some files you do not want to share with other people, like for instance etc password. Of course, your company, you have files that are specific to your company. There's an easy way to customize these rules and to say, hey, we have like 5 files over here and 6 files over there. We really want to make sure that these files are not going over to to somebody who's not authorized to see these files. So you can actually customize these rules and say, hey, I really want to make sure that these files are not leaked out of the company. We flag email addresses. So in the BlackBerry case, this, if you would scan the source code, we would flag this as an issue. Of course, there's a legit use again of having hard-coded email addresses in your application for the administrator, for instance. Other options or other things we do, flagging all mailing APIs. If you are not using any mailing in your application and at some point you see some mailing happening in your application, that's pretty odd, right? So we flag all mailing APIs. And then it's up to the auditor again to figure out if you really have a mailing capability in your application or if this code was added by a malicious insider. Dynamic code injection and manipulation. So we flag functions like field set accessible that can change read-only variables. Again, we looked into Jeff Williams' paper, and we flag at least all his examples, but we actually elaborated on his work, and we do even more than what he is describing. This, as the person over here said, people can take these examples and start thinking about it and start saying, hey, and if we do this and that, and craft their insider code better to actually not be discovered by our tool. Obfuscation and camouflage. If you're using a single equals in an if statement, we flag that. So the root in Linux case will be flagged. We identify variables with the same name as common functions. So all these common functions, if you try to have a variable in your application with one of these names, that will not be possible if you're scanning it with this particular rule set. We will flag that. We report decoding operation on hard-coded strings. There's no, you should never have like hard-coded strings in your application and decode them on the fly. If they are hard-coded, why are they hard-coded? Do you really want to hide something from your developers itself, or what's the deal over there? So decoding hard-coded strings in your application is really odd, and we definitely flag that. I have to say, this is not a regular command injection. So if you will scan, so the first example, if you will scan that with default rule set, this will not be flagged as a command injection because it is not. It is not a command injection because the string itself is hard-coded in the application. It is not, the user does not have any control over it, so it's not any tainted data that's coming in from the outside world. Last example is decoding, example 2 is decoding on rod 13. We do flag that stuff, and I have to say this is one of the most useful rules we had in our rule set. We actually found real issues over there where people have like simple decoding mechanisms, customized decoding mechanisms. We do find that, and that's one of the examples that showed up over here. Okay, conclusion of my talk, and I think this will be the interesting part for you guys. So how do you avoid getting caught? Make your code look as real as possible. As this person said, try to figure out what your application is really doing. Make sure that if you're having, or if you're decoding stuff, do it in a place where actual decoding is happening. If you're executing queries against the database, at that point, insert your new execution of queries against the database. Try to make your code as real as possible. But also understand the defender's capabilities. So use tools. If you know of tools, like if you know of this insider threat rule pack, try to get a hand on it and play around with it, figure out what it is doing, what bad stuff we are doing. So if we are not doing really good in a particular category or whatever, just try to land in that category. For instance, if over here, if you're using a lot of time functions in your application, well, our tool will do bad because a lot of issues will show up in that category. Make sure you land in that category. Make sure you have an insider threat that uses time and that land in that huge bucket that is really hard to get through. So land in that bucket. On the other side, so please don't do it. It's not worth it, and we will catch you. Catching malicious insider, it's really like looking at like a needle in a haystack. We've seen code scans where there were like thousands of issues showing up, and then you have to find that one real insider threat thing. So it's really looking like a needle in a haystack. And we're moving in the right direction, but I think most companies are not looking for the insider threat. They are just ignoring it. They think everything is fine, all their developers are fine, and if you lay them off, they're happy or something. I'm not sure. So we really have to have a systematic approach, and you have to do it throughout the life cycle of your product. So it's not enough to just look at the source code. You have to also do it in QA. You have to do it in the running application, where you have to figure out where the malicious insider is and catch him. I think that's pretty much it for my talk. Are there any questions?
Yes. What can you do against an insider that is using your tool to check that his own modification of the code of what is injecting in the code is not detected?
Yep. Well, if you're an insider and it's not detected, you're happy. If it is detected, you try to modify it and make it in such a way that our rules.
If I'm an insider and that I'm using your tool,
yeah,
and I produce code that is not detected, my question is that, as an employer, what can you do?
No, that's first of all, the insider threat is lucky. He's lucky. He's really good. So he did the stuff he wanted to achieve. But do not forget, we produce updates on this rule pack. So this is a living thing, you know. What we will not find today, we might find it tomorrow. So, and it's a cat and mouse thing. So we're sure that we scanned some code bases and did not find anything. That does not mean that there is no insider threat in the application, for sure. That's why I'm saying you have to look at different levels. We did it from a technical perspective, but HR can help you over here. Other people in the company can help you detect the malicious insider. There's a couple of questions.
You said that you were looking for decoding functions in code. How do you do that? Are you just looking for strings that look like decode? Or if I write my own function with an unsuspicious name, wouldn't you find that?
Okay. Again, good one, because you're already thinking like an insider. You know that we are going to look for decoding functions, which is true. So first of all, we know of, we looked at the web and figured out all the packages with decoding functions. So we covered them. Then of course, this is like a high issue, because we know these are really decoding static strings or strings and data in general. Then what we also do is, again, we look for names. If you have decode, we actually did it in a couple of languages, I think. So if you try to decode and you translate it, so we look for the string itself. But then, of course, what you're saying is true. Again, if you know about this, if you know we are doing that, what you are doing is like, hey, I'm going to call it something else. So yeah, you're completely right over here. On the other hand, it's not limited to decoding. You still have to do something with it, you know. You took something, you took a suspicious string, maybe we find your string. So it's one thing, it's these breadcrumbs that we are trying to look for. You hide from one thing that we're not finding, does not mean we will not find the other stuff.
This was a question about the manual review, which you mentioned and said that it doesn't manage to capture a lot of times. Is that because based on experience people don't manage to catch it? Because I'm trying to figure out, if I see a code and I don't see the content of what is going on, or the context of what is this command is there, I would be suspicious. And you're saying that because we would miss the equal sign, and that is a normal thing. But doesn't the process should be a manual code review, which is at the same time simultaneously being done with that? It shouldn't be done at the same time, the manual and the automatic code review.
Well, I think this rule pack can only help the manual code reviewer, because it gives you pointers in the code where you should start looking. And your first question about how do I know that the code review is not effective? Because we find stuff in a code base that was manually code reviewed. So there was a manual code review done on the code base, and afterwards we ran our toolset on, our inside the threat rule pack on it. It showed a couple of pointers, and if you dived into that, it was like, this is not really, this is like an additional functionality to the functionality that had to be in the code base.
So what you're saying eventually for me, it's like saying that when you had the oil spill right now in BP, and the fact that somebody should actually do a check and he doesn't do a good check, then the fact that doing a check is not a good solution. I think the fact that the manual code review probably as a process is not a developed process enough. There's not enough effort put into it, so it's more procedural and more understanding of the organization rather than bad manual code review. A good manual code review should capture everything eventually.
Oh yeah, but and then what does NASA pay for one line of code? Then you're in their stage, you know, you're paying like 50 grand for one line of code in the space shuttle. That's how they do manual code review. They go through each line of code or something. So that then you're on the NASA side. There's still a trade-off between, hey, we have to produce code, we have to push it out at some point, you know. So for sure, then there's lack of experienced people in the code review team, for instance. Sure, but there's definitely a trade-off. If it's spread out over your entire application, this is really hard to spot sometimes.
It seems to me that different developers write different parts of the functionality of a whole application. So that would mean that some people would write code that handles dates and timestamps, and other people would write code that should never do that.
Yep.
Do you adapt the rules to who has written a certain piece of code?
No, we do not. So we look at the entire code base. It's a good point, and
flagging employees who have left
separation
the
of concerns.
company,
Yes, separation
flagging
of
code
concerns.
that is written by someone who has left the company seems like a good hint too.
Oh yeah,
So
true. Absolutely. So yeah, that's a really good hint. If somebody left the company and all these normal issues become at this moment like high issues because you really want to dive into, yeah, that's a really good point. No, we do not do that at the moment.
Anyone else? Benny, perhaps?
Okay.
Thanks. Damn. Where are the arrows? The rockets?